I'll just give you a vague idea. See, a logarithm is a way of representing bigger numbers and small. You're playing all in terms of exponents. Okay. So let's say when you write log, say log of x to base b. This is called base. This is called base, and this is the number, which is the argument. Okay. Log of x to base b gives me a number, say y. Okay. What does this mean? Now, this you can understand only if you hear me out. Hear my definition. Log of a number to a base gives me the exponent to which the base must be raised to get this number. Again, log of a number to base gives me an exponent. So y is actually an exponent. What exponent? To which the base must be raised to get the number. Do you understand? Now, the basic that we said, let's now take log of both sides. Say taking log to base b on both sides. Okay, on both sides. Say from this particular statement. So what it happens, it becomes log b to the base b to the power y is equal to log b x. Correct? I can write this. And this one I told you, this is always y log b to the power base b is equal to log b x. Now log b to base b will always be 1. See, any number to the base logarithm has to be 1 because 1 is the exponent. B to the power 1 is b always. Yes or no? So you get back to the same thing. Y is equal to log of b base x. In integration differentiation, this base is always the exponent e. We can take base to 10 also, which means some basic things that you can understand. Let's say I write 10 square is equal to 100. It means log of 100 to base 10 is always 2. Okay? Log of a number to the base is always 2. Clear? Another thing, similarly, if I write e to the power log e base x, e and log are known as, this is the inverse of this. Exponential is the inverse. They're just cancelling these two, it will be x only. This value will be x only. E to the power log means e and log are exponential, means inverse to each other. So just cancel. Now it brings one more thing. Log you can never take of a negative number. You can never take of a negative number. Log is always of a positive number. Just think. Just think. Is there any number b whose exponent, if you make y, can you ever get negative? Just think. B to the power 0 is 1. B to the power 1 is b. B to the power minus 1 is 1 by b. You can never get negative. Right? This is never possible. Which means x can never be negative. Keep that in mind. Logarithm of a negative number is never possible. Never ever possible. That much knowledge is enough. Just to tell you about logs, and we will use the log fond of basics, like log of products is equal to sum of individual log, log of division is equal to difference, and the exponent one. Right? Shall we go ahead? Now, you won't get a logarithmic differentiation directly. You will get problems which involve logarithmic differentiation. Let's take some example. Let's say somebody asks you, I'm taking the book example, x equal x minus 3, x squared plus 4, x plus 3, x squared plus 4, okay, this x minus 3, okay, 3x squared, 4x, 5. 3x squared, 4x, 5. Okay, let's do it. Let's say this is x minus 3, 3x squared plus 4x plus 5, and the entire thing is under a root. We have to differentiate this. If you differentiate it with the standard way, you will spend the whole day, you will not end up in anything. It will be highly complicated. Here we take logarithm. Now, how do we take logarithm? It's like this. See, we can write y is equal to x minus 3 multiplied by x squared plus 4 divided by 3x squared plus 4x plus 5, and the whole thing can be written as half. Do you agree with me or not? Right? Now we take log of both sides, okay? Taking log means log E, log base E. In differentiation, it is always E. So children, there is two things. If you write this, it is correct. If you write this, it is correct, log natural. But India, people have made a practice of writing log in calculus. It is understood that it is E, it is not with respect to 10. So taking log of both sides. Okay, let's take the log of both sides. Then what do we get? We get log of y is equal to log of this whole term, log of 3x minus 2 x square plus 4, 3x square plus 4x plus 5 to the power half. Okay, bacha? This much is understood. Now, log y equals to half log. Now, here we are using the first formula, that is the exponential formula. Okay, which is 3x minus 2 x square plus 4, 3x square plus 4x plus 5. Did you understand this formula? This formula is this. See, if you have log a to the power n, this is written as n log a. This is a formula. You can again write it if you have any confusion. Fine. Now we differentiate. Differentiating both sides with respect to x. Now try and differentiate. So we write our process as d dx of log y is equal to d dx of half log 3x minus 4, no? Minus 4 or minus 2? Minus 2. Sorry, 3x minus 2 x square plus 4 multiplied by 3x square plus 4x plus 5. Is this fine? Understood? Okay. Do you need this to be opened up, or can you do it like a chain? Yeah, I'll open up. Okay. So how to open up? You cannot differentiate y with respect to x. You can always differentiate it with respect to the variable. So we will write it as d dy of log y, but you have to do dy by dx. So I'm making dy by dx. Now just see. This dy cancels. So basically you have done a d dx of log y. So you always differentiate it with respect to the variable, right? But this side we can straight away differentiate because everything is in the order of x. So we write half can come out. Okay. Now look. Now can I write it like this? D dx. Now here there will use log rules. Log of a into b is log a plus log b. Okay. So I can write log of 3x minus 2 plus log of x square plus 4, and this whole thing is being divided, so I can write minus log of 3x square plus 4x plus 5. Children, just see this step. Have you understood this thing? Did you understand? Okay. If you have not understood, we can again write here log of a product AB is log A plus log B. Many children think log A into log B is log A plus log B. That is not possible. How can a log A into log B be log A plus log B? Log of AB. Okay. And the other rule that we used was log of A by B is log A minus log B. These are the three things which should be down your heart. These three. Okay. Now let's differentiate this. D dx of log y is 1 upon y. dy by dx. So children, you are actually supposed to find out dy by dx. So we'll transfer the y that side later on. And the y is already known to us. Y is this particular term. This is what is y. So let's first clean this mess. So this is half. Now tell me, how do you differentiate log of 3x minus 2. Now here again, Joey, for you, chain rule. ddx of 3x minus 2 log of. So how will you do it? dd 3x minus 2 into d 3x minus 2 by x. I will not write the steps, but hold on writing. Just see how I am doing. This is cat, log cat. I will do dd cat of log cat. What is dd cat of log cat? 1 by cat. So dd cat of log cat is 1 by cat. Is this understood? Into d cat by dx, which is 3. Got it? Into d cat by dx, which is 3. Hold on, you will not write. Let's do the next one together. This is dog. dd dog of log dog, 1 by dog. So we get a x square plus 4. This is 1 by dog. Into d dog by dx, which is 2x. Fine, bacha? Did you understand? Okay. And this is mouse. dd mouse of log mouse is 1 by mouse. Agreed? And then we will put a bracket out here because this is a negative. And then d mouse by dx, which should be 6x plus 4. Have you understood? I will wait for you. You can write this step now. And while you are writing, you do it looking at your book only from your step. I'll take some time. Don't worry. Because in this chapter, these sort of things will come a lot. Chain is always like that. dd dog of d dog. That way you do. Okay. So now our job is to just keep dy by dx this side. That is what you were supposed to find out. And you transfer y this side. So it becomes y by 2. Shall we clean it up a bit? 3 by 3x minus 2 plus 2x by x square plus 4 minus 6x plus 4 pretty easy. Now the last step. Our last step would be dy by dx is equal to, now you bring your y. What was your y? X minus 3, then x square plus 4, 3x square plus 4x plus 5. Then you have a 2, okay. Then you have a root of this. You have the half. This is y multiplied by 3 by 3x minus 2 plus 2x by x square plus 4 minus 6x plus 4 divided by 3x square plus 4x plus 5. That's it. Done. Okay. It's all about keeping your the next problem is a standard formula which we use, but still we'll do that. Done, children? Shall we? Let's go. The next, this is a standard formula, okay? So the question is y equal to a to the power x. Was it done for you, Sarthak? Okay. Y is equal to a to the power x. Same. So we'll take log of both sides. So taking log of both sides, what do you get? Log y is equal to log a to the power x, which can be written as x log a. A to the power x is x log a, right? Now you differentiate. Differentiating both sides with respect to x. So you get a ddx of log y is equal to a ddx of x log a. Okay, so let's see this again. So you see this is log y, log cat. So dd cat of log cat, 1 by cat, which is 1 upon y into d cat by dx, which is equal to log a is a constant now. ddx of x is equal to 1. Fine. And what do we have to find out? Sorry, what is the log a? And it is multiplied by 1. So we have to find out dy by dx, which is equal to y log a. And y is nothing but a to the power x log a. So this is a standard formula, beta. ddx of a to the power x is a to the power x log a. This is a standard. Fine. Let's see one more. This time our question is y equal to x to the power sine x. Whenever you see to the power and all, it's all log problem. So we take log of both sides, write down, taking log of both sides. Let's see, what do we get? We get log y is equal to log of x to the power sine x, right? Which can be also written as sine x log x. Clear? Now we differentiate. Differentiating both sides with respect to x. When we differentiate both sides with respect to x, I write a ddx of log y is equal to a ddx of sine x log x. Now mind you, these are two functions, trigonometric multiplied with logarithmic. So our product rule will be applicable, which is ddx of ux vx. So this side let us solve first. dd cat of log cat, 1 by cat into dy by dx. And here first function into differentiation of second function, which is 1 by x, plus second function into differentiation of first function, which is cos x. First function, okay, this can be also written as, see, sine x ddx of log x plus log x into ddx of sine x. First function. Are we ready now? So dy by dx is equal to y times sine x plus x cos x log y divided by x. And now we multiply with the y. So let's multiply with the y. Our y's value is x sine x. So it is x sine x multiplied by sine x plus x cos x log x divided by x. And this x and x can go up. The final answer is sine x sine x. So you can write sine square x plus x cos x sine x, your wish, the way you want. Our problem is solved. Did we get this one? Okay. Before going to the exercise of logarithm, what I'll do, I'll also teach you parametric differentiation. Then we'll do the two exercises together. We'll spend time, don't worry. Okay, next problem. Our next problem is y to the power x y to the power x, x to the power y. No, I'm unable to see it also. Y to the power x, x to the power y, and x to the power x. Okay, x to the power x, yeah. So question is y equal to y to the power x plus x to the power y plus x to the power x. Okay, no, it's not y equal to, they are saying that, 1 minute, huh, children, this is not y equal to, they are saying differentiate if this is equal to a to the power b. It's an equation. You have to differentiate this. We have to differentiate this. It's a to the power b. And they are saying differentiate, find dy by dx. Means they are asking you to differentiate with respect to x. Basically, you have to find out the value of dy by dx, right? In this case, we will do some assumptions. Let's see. We say let y to the power x be equal to u and x to the power y be equal to v and x to the power x be equal to w. Okay. If you do these assumptions, then your problem, see, please understand, y is a function of x. There is x here, there is x here. These are also basically x-related functions only. Our problem becomes u plus v plus w is equal to a to the power b. Agreed? Okay. So now we do differentiating both sides with respect to x. You get a du by dx plus a dv by dx plus a dw by dx, which is equal to 0, because differentiation of a to the power b, a and b are both constants, so this will be 0. Fine. Number 1. Sorry children, sorry. Solving du by dx, du by dx, okay? How do you solve it? U is equal to y to the power x, log u is equal to x log y, right? 1 by u du by dx. Got it now? If you differentiate, dt cat, 1 by cat du by dx. So let's differentiate this side. It will be x into dy of log y is 1 by y into dy by dx. Okay, into dy by dx plus log y. Is this clear? First function into differential of second function. So from here, we need the value of du by dx. Du by dx can be written as u into x dy by dx 1 by y plus log y. And further we can write du by dx. This is a lengthy problem, 3 problems punched together. Y to the power x multiplied by an x, okay, and then you have another y into 1 by y. This is 1 by y. Okay, yeah, you will multiply both, so it becomes x y to the power x into a y dy by dx plus y to the power x log y. So further we can write du by dx is equal to y and y, x y to the power x minus 1 dy by dx plus y to the power x log y. Just check whether we have got this. Yeah. They have retained it at this step only. In the book, they have retained it up this step. In fact, I have put there also y to the power x. Yeah, fine, we are fine, nothing wrong. Now the next differentiation we have to do. Okay, number 2, solving dv by dx. Let's do. We have taken what? V is equal to x to the power y. So x to the power y. So log v is equal to y log x. This becomes 1 by v dv by dx is equal to y into x is 1 by x plus log x. Log x will be dy by dx. This is pretty easy. So our dv by dx now becomes equals to v times y by x plus log x dy by dx, which is equal to, instead of v we write x to the power y into y by x plus x to the power y log x dy by dx, which is equal to x to the power y minus 1 y times x to the power plus xy log x dy by dx. Finally, children, you have to get the value of dy by dx. So 3 dy by dx terms will come. We will take common and we should be able to do it. Is this much okay? So these are your important findings, okay? So far, your findings. One finding is this. One finding is this. And the third finding we are going to find. Why are we finding such third findings? You have solved this. You have solved this. Now this one remains. Which one? How did this come? How did this come? Okay, let's see. Now, first function is y. Y into ddx of log x, 1 by x. Clear your doubts as you go. Now we have to find dw by dx. Can I change now? Okay. Okay. Now solving the third one, dw by dx. The third. Solving dw by dx. You had said that w you had taken as x to the power x. So let's do log w is equal to x log x. Let's do the differentiation now. 1 upon w dw by dx becomes equals to x into x plus log x into 1. Right? So dw by dx becomes equals to w times 1 plus log x, which is equal to x to the power x plus x to the power x log x. This is dw by dx. Time for us to do the final compilation now. So the final compilation was all three differentials equals to 0, that is du by dx plus dv by dx plus dw by dx all equals to 0. This was our final compilation. So let's start adding our compilations. This is xy x minus 1. This is xy x minus 1. And then we have dy by dx yx log y, dy by dx plus, what was it, yx log y, y to the power x log y. Now we come to dv by dx yx y minus 1, yx y minus 1 plus xy log x dy by dx plus x to the power x plus x to the power x log x is equal to 0. Right? So careful here. We have one dy by dx term and another dy by dx term. So let's take some common from here. So it becomes xy x minus 1 plus xy log x dy by dx is equal to, now everything goes as negative. So negative of x log x, this term is gone, minus x to the power x, this is gone, minus yx y minus 1, this is gone, all right, and this one yx log y plus, not plus, sorry, these are all plus yx log y. Okay, so this term is also gone. You finally can say dy by dx is equal to negative of x log x plus x to the power x plus y to the power x y minus 1 plus y to the power x log y. We'll have slight difference of answers maybe with book. xy x minus 1 plus xy log x. A slight change with the book, but we need not worry. Yeah. So the answer is in the bottom, xy log x, xy log xy x minus 1, denominator has tallied, negative of y to the power x log y, y to the power x log y, plus yx y minus 1, yx y minus 1, plus x to the power x log x. Okay, this is, children, 1 minute, this is x to the power x, one small thing, this is x to the power x. Yeah, x to the power x. Yeah, it is completely tallied. Perfect. Got the answer? Okay. This is all about logarithmic differentiation. Our next type of problem is called parametric differentiation. Let's learn that also. Parametric, very easy. Parametric. Parametric means, see, what all type of problems did you see so far? Where y was explicitly defined. When you started differentiation, with very kiddo problems, where the problem used to be y equal to sine x. Do you get it? Y equal to sine x. There y is explicitly defined in terms of x. Very easy differentiation. Then what did you get? You got problems which were implicit functions. What were implicit? You got a x plus y sine x. Then you used to differentiate both sides, and your job was to push out dy by dx on one side. Just this, the last problem that you did, that's like an implicit. Implicit, where logarithm was used as a tool. Before that, you used to do only implicit. Now, suppose function is neither implicit nor explicit, but the functions are like this. See, suppose x is a function of some variable t. At that time, y is also some function of t. How do you differentiate? Okay, it's very simple. Differentiate this dx by dt. So you get what? You get a differentiation of you f dash of t. You will get differentiate with respect to t. Got it? And you differentiate dy by dt also. You get what? And this is, say, a function of, this function should have been different. This should have been some g. Okay, this is some function g of t. So this becomes g dash of t. Now you have both the values. Did you get it? Now, what does it become? Your dx becomes f dash t dt. Right? And what does your dy become? G dash t dt. Okay, is this much clear? You have just cross multiplied. Now combine these two and you want to find out dy by dx, which is very easy. G dash t dt divided by f dash t dt. The two dt's cancel each other. That's your dy by dx. That's how we do it. This is a basic funda. Okay. Did you understand? Your x and y will not be will be in terms of some third variable. So let's take one problem, then it becomes easy. They have asked us to find dy by dx, and the conditions they have given is x equal to a cos theta, y is equal to b sin theta, I think, or a sin theta. It's a sin theta. Okay, a sin theta. Now see, children, x is a function of theta, y is also a function of theta. Got it? So you need to find dy by dx. So we will do what? We'll just use dx by d theta. Here t is theta. Here t is theta. So dx by d theta. What does dx by d theta give you? Dx by d gives you minus a sin theta. Yes. And what does dy by d theta give you? A cos theta. Clear? Can I write it like this? See, your book will write it like this. Your book will write dy by dx is equal to dy by d theta divided by dx by d theta. Your book will write like this. It's the same thing. I am saying, and I write it like this. Dx is equal to a sin theta d theta. Dy is equal to a negative, a cos theta d theta. Okay? So put it negative a sin theta divided by negative a cos theta. Both gone. Sorry, not negative. Sorry, a cos theta. A cos theta. Both gone. Your answer is negative of tan theta. Done. That's so easy. Negative of tan theta. Did you get it? Chalo, एक और करते हैं. Let's do one more parametric differentiation. Can I start? Our next parametric differentiation is x equal to 80 square. Find dy by dx. X equal to 80 square. This is your physics wala type. And y is equal to 280. Y is equal to 280. Can you do it on your own? Try. Solution. How to do? We'll do dx by dt. Tell me dx by dt will be 280. dy by dt is equal to 2a. Then dy by dx, which is equal to 280. Sorry. 2a divided by 280. 1 upon t. Fine. Let's do one more. Okay. Our next question is a theta plus sine theta. Next question is x equal to a theta plus sine theta. And y is equal to a 1 minus cos theta. you are supposed to find dy by dx. Shall we? So let's start. Dx by d theta. Dx by d theta. Now how do you do it? Look, you just open it up. A is your constant, so a can be a. d theta of theta is 1 plus cos theta. Did you understand this? Okay, and on this side we have dy by d theta. A is my constant, dy of 1 is 0, d theta of 1 is 0, minus of minus becomes plus sine theta. Dekh bacha, have you understood or not? Okay, now dy by dx. dy by dx is a sine theta divided by a into 1 plus cos theta, which is equal to sine theta by 1 plus cos theta. Okay, now you will say, sir, the answer is not tallying with the book. Let's make the answer tally with the book. Now here some trigonometric juggleries will be used. Is this much okay? Okay, and let's see some trigonometric juggleries out here. So our juggleries are sine 2 theta is equal to 2 sine theta cos theta. Children, do you agree or not? Right? That means a sine of theta should be 2 sine theta by 2 cos theta by 2. If 2 theta gives you theta theta, theta should give you theta by 2 theta by 2. Agreed? Then cos 2 theta is 2 cos square theta. Cos 2 theta is 2 cos square theta minus 1. Agreed? That means cos theta should be equal to 2 cos square theta by 2 minus 1. Agreed? That means 1 plus cos theta is equal to 2 cos square theta by 2. Agreed? Shall we now put those here? This becomes 2 sine theta by 2 cos theta by. See children, if you leave here also it's full marks. And this is 2 cos square theta by 2. 2 and 2 cancels. Cos square and cos cancels. Answer becomes equals to tan of theta by 2. That's the book answer. If you leave here also, it's nothing if heavens don't fall. Next problem, and next is thoda sa tricky. X to the power 2 by 3, y to the power 2 by 3, x to the power 2 by 3 plus y to the power 2 by 3 is equal to a to the power 2 by 3. Find dy by dx. Again, here also we have to make it parametric. Now when we make it parametric, it's something like this. Look, ultimately you just can't assume something. When you assume, this equation should be satisfied. Just let's see. Let x equal to a cos cube theta. Cos cube theta. This is 3, that's why 3. Okay. And y is equal to a sine cube theta. By doing this, this equation must be satisfied. Just check. If you do this, let's see what is the LHS of the equation. The LHS becomes a cos cube theta 2 by 3 plus b sine cube theta 2 by 3, which gives you a to the power 2 by 3, right? Sorry, not b, y is, this is a. So much of mistake I do. This is a. And this becomes cos square theta plus a to the power 2 by 3 sine square theta, which is nothing but a to the power 2 by 3 cos square theta plus sine square theta, which is equal to a to the power 2 by 3, which is RHS. So your assumption has nothing wrong in it. Your assumption is absolutely fine. We didn't solve the problem. We just checked whether our assumption is correct or not. Did you understand? This assumption is valid. Now we do our problem. So what's our problem? X is equal to a cos cube theta. Chalo, let's do this. So dx by d theta. Can anybody do dx by d theta? Look, power function angle. Always remember power function angle. So how will you differentiate it? Shall I show steps broken for this one? Steps completely broken. So this will be dd cos theta into cos cube theta into d cos theta divided by d theta. Power function angle. First treat the power, then treat the function, and if there was an angle, then you treat the angle. So dx by d theta becomes equals to what? Dx by d theta becomes a 3 cos square theta into negative sine theta. Just see, children, did you understand? A cos theta is negative sine theta, and this becomes 3 cos square theta, nx n minus 1. Similarly, we had y is equal to a sine cube theta. So dy by d theta becomes equals to a into p sine square theta into cos theta. I jumped a step here. Which I've shown open. So finally, what I'm supposed to do? Dy by dx, which is 3a sine square theta cos theta divided by how much? 3a cos square theta sine theta. 3a cancels, sine theta cancels as square, cos theta cancels as square. This becomes tan theta. But tan theta is there will be a negative tan theta. Thank you, beta. There will be a negative tan theta. But tan theta is not allowed, child. Theta you can't have. So you take out tan theta from here. Just see, if I do y by x, then what do I get? A sine cube theta divided by what? A cos cube theta, which is equal to tan cube theta. That means tan theta has to be cube root of y upon x. So I substitute here cube root of y upon x with a negative. That's my answer. Samjhi? You can leave at theta. Theta is not allowed because you have to get your answer finally in the form of x by y. Now you have 5.5, 5.6, right? Shall we see some second order derivative? We'll take next class also, we'll do problems. Since starting a problem will not help anything, let's see second order derivatives. That is the last part of this chapter. Next class we'll do all, but I expect you all to do some exercise problems on your own and then come. Is this okay? Let's see second order derivative. Very easy. Second order derivative is differentiating 2 times. And I'll straight away not give any gyan. I will do problems. Second order derivative question. Let's just do straight away with problems. Y equal to x cube plus tan x. Very, very easy. Y equal to x cube plus tan x. Tell me, children, is this an explicit function? Yes. I have to differentiate it twice. Right? So let's understand like this. If I have a function y is equal to fx, the first derivative is known as y prime, which is nothing but dy by dx, which is shown as f dash of x. I think, children, you know this. These notations are known. If I differentiate this 2 times, it's y double prime is nothing but y prime of y prime, which is nothing but d dx of dy by dx, which is nothing but d2y by dx2, which is nothing but f double dash x. That is how we write. We are differentiating. Derivative will also be a function, na? Just differentiate that function. Chalo, let's do it. Come, very easy. Let's do dy by dx is what, children? 3x square plus sec square x. You remember or not? ddx of tan x is sec square x. Got it? Now we have to do second order derivative. d2y by dx2. d2y by dx2 will be 6x plus ddx of sec square x. So it will become 2 sec x multiplied by sec x tan x. What is ddx of sec x? Look, your formula sheet should be there. ddx of sec x is sec x plus tan x, or sec x tan x. If you have a confusion, I am having a confusion on ddx of sec x. I have a confusion. I don't remember. Let's deduce it. This is nothing but ddx of what? 1 upon cos x. Agreed, children? So this should be cos square x gx square cos x into differentiation of 1, which is 0, minus 1 into differentiation of this, which is sin x. So our answer comes positive sin x, and cos square x is what? You can keep 1 cos x here and 1 cos x here. So this thing was wrong. There won't be plus, it will be just sec x tan x. So this is sec x tan x. Got it? Sin x cos x is tan x sec x. So my second derivative is equal to 6x plus 2 sec square x tan x. That's so easy. You just have to differentiate the function twice. Clear? Let's do one more. All examples we will finish. Y equal to a sin x. Y equal to a sin x plus, I think, b cos x. Y equal to, this problem comes even in differential equation. Okay. Y equal to a sin x plus b cos x. Prove that. You need to prove d2y by dx2 plus y is equal to 0. You have to prove this, right? So in order to prove this, we have to first get this value, and this value is already known to us. So let's get this value. So we do dy by dx. Solution. Chalo, dy by dx karte hain. dy by dx will give me a cos x minus b sin x. Clear? Now second derivative. d2y by dx2. Negative a sin x minus b cos x. Now let us prove this. LHS is equal to d2y by dx2 plus y, which is equal to negative a sin x, negative b cos x plus y. Y is what, beta? A sin x plus b cos x, and we have made it. This is 0. RHS, which is proved. Very, very easy. Neha, this problem is there in the new book, which I did right now. Just check. Second order derivative. Can I change screen?
Yes.
Okay, let's do one more. 3e2x plus 2e3x. 3e2x plus 2e3x. This is given to you. You need to prove. What do you need to prove? You need to prove second derivative minus 5 times first derivative minus 5 times first derivative plus 6 times of y should be equal to 0. This is what we have to prove. So we need first derivative, we need second derivative also. So let's find out the first derivative. Dy by dx should not be a problem. So 3 is 3. How do you do it? Look, e to the power cat. So you will do dd cat of e to the power cat, which is nothing but e to the power cat into d cat, that will be 2, plus 2 e to the power 3x into 3. So basically this is 6 e to the power 2x plus 6 e to the power 3x. This is done, right? Pretty good. Then we have to do d2y by dx2. Do it. So this becomes 6 e to the power 2x into 2. So 2 is multiplied here, and this becomes 2, not 2. This becomes 3 multiplied by 6 e to the power 3x, right? So this value becomes 12 e to the power 2x plus 18 e to the power 3x. Now we need to get to this thing, our LHS. So our LHS is 12 e to the power 2x plus 18 e to the power 3x. From here we have to deduct 5 times of this. So 5 times of this means 5 6 are 30. 30 e to the power 2x and 30 e to the power 3x. Let's just do this portion first and then we will add up. 30 and 12. 30 and 12 gives you how much? 18. Negative 18 e to the power 2x. Okay. And here we will get negative 12 e to the power 3x. With this we have to add 6 times of y, that is 18 e to the power 2x plus 12 e to the power 3x, and this cancels each other, we get a 0. Did you understand this step? Children, this step is this step, and this step is this step. Okay, one more example is there. We'll take up next class. If you wanted to give a try, you can give a try at home, but at least do some problems from 5.5 and 5, whatever is your exercise, 5.5 and 5.6. If you bring your selected examples, we can do selected examples. So one last class on Thursday and differentiability ends, and we start with application of derivatives, and that means this book is finished. So is there anyone? One more example is there. Sine inverse x, like here only itself, this one. Try that example on your own if you can. And if you're not, leave it. But I at least want you to do some problems of what do you call logarithmic differentiation, some problems of parametric selected, so that next time when we come to class, we are able to wrap